All right, hello geometry students. Here we go. We're on 4.3, our third and final lesson for this week on congruent triangles. And so we're slowly building up to learning to do triangle proofs. And so we got just two definitions and then a couple practice problems from the textbook. So here we go. First definition, corresponding sides and angles. So what does it mean to have sides and angles that are corresponding? It's when they are in the same position in polygons with equal number of sides. Okay, so what we mean is if I draw two shapes here, now let me go and scroll up, get enough space. So if I have a triangle, look something like this. Actually, I want to make it look a little more different than that. We'll do that. Okay, and then we have another triangle that has another polygon that has the same number of sides. Then what we have here, and I'm going to label this one. We'll call this one A, B, C, and we'll call this one D, E, F. And so when we say which sides correspond, we're talking about the ones that are in the same position. And so in this case, you have the fact that angle A right here in the top left, that corresponds to angle D because it's in the same position. And then we have B corresponds with E, and we have C corresponds with F. Okay, it's because they're in the same position. So when we're talking about corresponding, it just means ones that have the same position. We had the same thing with corresponding angles in the transversals. And then when it comes to side lengths, same idea. And these I'll just actually list out. But in other words, segment AB corresponds with segment DE. And segment BC corresponds with segment EF. And I made this kind of easy because I put them in the same position, but even if they were twisted, I'd want to identify ones that were in the same position. And the last, AC, corresponds with DF. Oops, let me write that a little better. And so that's all we're talking about in this first definition, is being able to pick up the sides and the angles of two polygons, and they'll have the same number of sides, and saying, okay, this angle corresponds to this one, and this side corresponds to that side. And so you want to be able to do that because we're going to be talking about how to prove them congruent. And if you can't match them up in terms of which sides correspond, that's going to be very difficult. Okay, so corresponding sides and angles. Then that gets us to congruent polygons. And so congruent means the same. And so congruent polygons are simply polygons. Sorry, I'm making a video. Polygons are with congruent polygons with congruent corresponding sides and angles. So in other words, that means you have two shapes. This time we're going to go with rectangles. All right, and we'll call this one A, B, C, D, E, whoops, E, F, G, and H. Alrighty, and so in order for these two polygons to be considered congruent, you actually have to know that all of the corresponding sides and angles are congruent. So for example, I would need to know that angle A, oops, let me do this in a different color. Let me do it this way. I need to know that angle A is congruent to its corresponding angle E. And I would need to know that angle B, I'm going to put 2 there because it's a different angle, is congruent to angle F right there. And that angle C is congruent to angle G, and that angle D is congruent to angle H. And again, I'm putting different markings in order to show that A and D are not necessarily the same, and F and G are not necessarily the same, but A and E are, B and F, C and G, and D and H. And that's just the angles. I would also need to know that all the sides are congruent. So we would need to know that AB is congruent to EF. Oops, not 2, just 1. I need to know that BC is congruent to FG. I need to know that CD is congruent to GH. And I need to know that side AD is congruent to side EH. And that's why we want to make sure we can know what's corresponding, because we want to know that this side and this corresponding side are the same, this side and this side are the corresponding same angle and angle. So all the corresponding angles have to be the same in order for you to say, okay, these two polygons are in fact congruent with each other. Okay, and we're going to be developing this idea through the rest of chapter 4. But for now, that takes us to our first question. But just to reiterate what I said, the question is, what is required to prove two triangles congruent? I actually wrote polygons here. Let me change that to triangles. And we'd have to say what we just said a moment ago. In order for the two triangles to be congruent, all sides, actually, got to change that even, all corresponding sides and angles must be congruent. Okay, and I can just kind of do a similar sketch of what I just did, but you'd have to have a triangle here and a triangle here, and we could call this triangle JKL and MNO. But again, I would have to know that all the corresponding angles, J and M, are the same. I need to know that K and N are the same. And I need to know that L and O are the same. And I need to know that JK is the same as MN. I need to know that ON is the same as LK. And that MO is the same as JL. Okay, so I need to know that all corresponding sides and angles are congruent in order to prove that two triangles are congruent. Okay, so then that gets us, don't worry, well, anyway, we'll give that away. Yeah, so all sides and angles that correspond. All right, and then that gives us now 4 problems from the text as practice. The first is just identifying corresponding sides and angles. So for number 4, 6, and 8, we are given the fact that triangle RST is congruent to triangle LMN. So that means that for number 4, segment LN is congruent to which part of the other triangle? Well, the key here is I could write these out, but just the point I want to make with this question is that just by the listing of the names, we know which parts correspond. If it says RST, then it corresponds by vertex to LMN. So in other words, if they asked for, I'll just do number 8. Actually, number 8 says angle N. Well, if N here is the last angle here, then it must correspond to this one right here, which would be angle T. So angle N corresponds to angle T. And then when it comes to sides, we can do the same thing. So LN means it's the line that connects the last to the first and the last vertices, LN. So that means it must correspond to the first and last vertices of this triangle. So it would be side RT or segment RT. Okay. So that's how we're just by the ordering of the letters, which is important. It's not random. It starts with RST. That means LMN corresponds in that same order. So if we say TS, which is this, which is last and second, or third and second, then it would be over here, third and second, or last and middle over here. So it would be segment NM. And in this particular case, well, you're completely wrong. The order does matter. If it says TS, I would not want to say MN because it didn't say ST, it said TS. So I want to be corresponding and say NM. So the order is important in order to correctly identify parts that actually correspond. Okay, so those are pretty basic. Number 11 then takes us to another level and indicates where we're going in chapter 4, and that is with proofs, proving triangles congruent. And so what we're supposed to do with number 11 is they are proving that triangle ABE, this one right here, is congruent to triangle CDE, this one right here. Okay, so that means in order to prove those two triangles congruent, you're going to have to know that all 3 sides and all 3 angles are congruent. All right, and so what they do on this one is they give us a given, and then they give us a proof, and we have to reason our way, give the reasons for it. So let's take a stab at it. But again, the goal is we've got to know that all these angles that correspond within, not this whole rectangle, but within those 2 triangles I traced, actually are congruent to each other. So let's see. They tell us that E is the midpoint of AC and BD. So in other words, E is right in the middle. That's going to be important because look, if E is in the middle, I know that AE is the same as CE. And I'm going to know that DE is the same as BE. So right then and there, I know that I have two sides of each triangle that are congruent. Okay. Also, they tell me that AB is congruent to CD. So that means AB, I'm just looking at the given right here, looking right there. First, I looked at this, and now I'm looking there. I know that AB is the same as CD. So without even getting into the proof, I'm reasoning my way through it. I can tell that all three sides of these triangles are in fact congruent because the midpoint gives me two sets, and then that other statement gives me the other set. And then it gives me this last given, and it might seem mysterious as to why, but we'll talk about it. It says that AB is parallel to CD. Okay, and we'll get into what that means based on the proof. Won't give that away right this second. All right, bear with me. I'll have to scroll up and down as we do this, but let's give the reasons. So they say AB is parallel to segment CD. Well, that's just right. Whoops. That's just right here. So my reason for that is given. Okay, so they tell me that's given. Then they say that ABE, angle ABE, is congruent to CDE. So ABE is this angle right here. And they are saying that CDE, so that's this angle right here, those are congruent. Why would knowing the lines being parallel tell me that those two angles have to be congruent? Well, I'll just sketch something and get rid of it. If I look at just that line, it said these two are parallel, and then it said this angle is congruent to this angle. Well, if you remember from chapter 3, what are those two angles to each other? They are alternate interior angles. We know that the alternate interior angles of within parallel lines are congruent. So that's how they did it. Once they knew that AB was parallel to line CD, then we know that those two angles are congruent to each other. And so the reason is alternate, I'd abbreviate, interior angle theorem. They also said that angle, I'm going to change colors just to differentiate it, BAE, they also said that this angle is congruent to DCE, which is this angle. How did they know that? Well, just it's a different transversal, but it's the same idea. Those are also alternate interior angles. And so that's why you have one reason for both those statements. Those two angles are now congruent to each other based on the alternate interior angle theorem. So now if you look at what we've sketched, we actually have two sets of angles in all three sides. All right, in the proof, they said that AB is congruent to CD. How did we know that again? How did we know that this up here was congruent to this down here, AB and CD? That was given. Okay, they told us that. It's right here underlined in red. So number 3 is given. And then they say that E is the midpoint of AC and BD. How do we know that? That was our third and final given right there at the top. So one thing they're doing in this proof is there of course, there were 3 givens, and now we've identified all 3 of those. Then they actually have given us the reason for this next one. They said that something is true because of definition of midpoint. I'll put this in black because they actually gave it to us. They said definition of midpoint. Well, what would they have been trying to prove by the fact that there's a midpoint? Well, we actually already talked about it. By saying that we only have one midpoint, it's the fact that E is the midpoint, and we said, well, because E is the midpoint, I know that AE is the same as CE, and I know that DE is the same as BE, those two segments. So that is probably what they just proved. My statement is that, I'm going to need to look at it so I can say it right, but AE, AE must be congruent to CE, and DE must be congruent to BE. Because if E is the midpoint, then it splits those lines into two equal sides. And so that is what they must be getting at through their reason definition of midpoint. Then they say that angle AEB and CED are congruent. So they're talking about, I'm going to get a third color, AEB is congruent to DEC or CED. How would we know those two are congruent? Ah, very good. Thinking back to your angle types, those have to be congruent because they are, yep, vertical angles. So that was not from a given, but we just can recognize that. So now look at what we have figured out. Based on the givens of E as a midpoint, we learned two sides here and here. Let me do it this way. We learned these because they were congruent, a midpoint. We knew that the final A, B, and C, D here and here are congruent because it was given. We know that this angle here in green are congruent because of vertical angles. And we know that the red and blue angles are congruent because they're alternate interior angles because they told us these two lines were parallel. So you can now see within those two triangles that we had to prove here and here, we have proven that all three sides and all three angles that correspond are in fact congruent. And so that's how we can get to the final statement here that the triangle ABE and triangle CDE are in fact congruent. And for this, we would simply write the definition of congruent triangles, which is, we said, all corresponding angles and sides must be congruent. Whew. Okay, that was a lot of work. And I know it was very new, and that's why I would recommend watching that again, or we'll be doing a lot of these in class together. Proofs can seem horrible until you just keep practicing again and again. I promise you will get the hang of it if you don't shut down and you don't give up and you watch these videos, maybe rewatch them. Over time, you're going to get the hang of it. You're going to learn different patterns. And you're going to find out that there is an easier way than what we just did. We just did a lot of work because we had to prove all three sides and all three angles. And I'll just give a little bit of a hint. It's not always going to be that much work moving forward. Okay. But again, go ahead and review these notes as the uploaded PDF, or watch that video again as we went through each item statement by statement and gave the reason for it. And we were finally able to prove the two triangles congruent here at the end because we had all three corresponding sides and all three corresponding angles proven congruent. All righty, look forward to talking to you in class and conquering the proofs, the triangle proofs from chapter 4. All right, see you soon.